So let's go to a bit more, somewhat more difficult identity, the trigonometric addition formulas. So what is this formula? You have cosine alpha, sine alpha here. What does that mean? It means that we have an angle of alpha here. So we go alpha up here, have a point. We have cosine beta, comma sine beta here, meaning that we have an angle beta. Here, right? So going from here and up there, you get this point. So I've also added these 2 points. So what are those? If you notice, if you take this piece of arc and add to this piece of arc, you end up here, right? And if you take this piece of arc and subtract this piece of arc, you end up down here. So you can see the difference between these two is the same as the difference between 0 and 1.0 in this point. Right? So I'll just, I have to do it over here, right? When the difference between alpha and beta shrinks, this also tends to this point, right? So what are the trigonometric addition formulas? Well, basically they are ways of calculating the coordinates of this point and this point, knowing only this point and that point. Okay. I'm not saying this is simple, but it's just a fact that you can do this. I won't prove it to you. If you want to calculate cosine of alpha plus beta, comma sine of alpha plus beta, knowing only the coordinates of these 2 points, what you have to do is to get cosine of alpha plus beta. This is a sign called plus minus, and here's a minus plus. The way to read this is to say if I want the plus version here, I should use the minus version here because they're both on top. There's a minus at the bottom here. So if you want the minus, you should use the plus here because it's on the bottom here. So the fact is, this is just a fact. You won't see any proof of this for now. To calculate this value here, so that number here, you take cosine of alpha, which is that number, times cosine of beta, which is this number, and then you subtract, if you want the plus here, sine of alpha times sine of beta. And then you end up with this x coordinate here. Then to get the sine of alpha plus beta, the y coordinate, you should say alpha plus beta. Sine of alpha plus beta is equal to sine alpha, the number up here, times cosine beta, the number here, plus, so plus goes with plus in this formula, cosine of alpha, so that's this number, times sine of beta, this number. Then, for some reason that it's not a simple reason, you get this number here, the y coordinate of this point. I don't expect you to remember this formula, but you should know where to look it up. Some of the formulas you will see, I expect you to learn by heart. This is not something I expect you to learn by heart, but you should know that it exists and you should be able to use it. So now we have found out how to find the coordinates of this. I could have done the same with this by just using the minus version here and the minus version here, so I should have used the plus here and the minus here. Right? Now, there's a different formula over here, right, and down here. So let me illustrate those. Let me take, say, 2. If we put both of these angles to the same value, alpha and beta are both equal, come on, move, to 2. These are supposed to be exactly the same, right? Then this formula down here simplifies, and this formula down here simplifies. Why? Well, alpha is now 2. Beta is now 2, right? This means that this is cosine of 2 times cosine of 2, right? That's cosine squared of 2. Minus sine of 2 times sine of 2. That's sine squared of 2. So that's exactly what I've written down over here, right? If we have the same angle, in this case I just used 2, right? But it could have been any angle. So if you put alpha equals to beta equals to theta, the topmost formula with a plus simplifies to cosine squared of theta minus sine squared of theta. Now we know that sine squared plus cosine squared equals 1, right? That was the fundamental identity of trigonometry. So if we add sine squared 2 times, then this is 1, but then we have to subtract it again. So we can also write this as 1 minus 2 times this, or we could have subtracted cosine 2 times, and then this would have been a minus 1, and then we should add them again, then we get the last identity here. But the first identity here comes from this formula with theta and alpha and beta equal to theta. The two last ones here are we have gotten from this by using the fundamental identity of trigonometry. We could have done the same with sine, and then it's much nicer to look at. It's just 2 times sine theta, cosine theta. Note that there's a sine here, cosine, and then there's a sine and a cosine. And they both come with a plus, right? So we add them and get this. And as you see, it's not simple to derive the coordinates of these two by just knowing these two. But it can be done. That's the take-home message.